All right, we can factor using the greatest common factor. That's what GCF stands for. If you're not sure how to find the greatest common factor, I would pause this video and go watch the video that goes into more detail on how we get a greatest common factor, because I'll kind of go through that piece a little bit faster here. All right, so we've got 4 things to factor. What you want to do is figure out what your greatest common factor is, and we kind of do that piece by piece. You've got a 20 and a 16. Biggest number that fits into 20 and 16 is 4. And then you have an x cubed and an x. And the most number of x's that they have in common, those two terms, is an x to the first power. So what we're going to do, our greatest common factor is 4x. We're going to factor that out of each of these terms. That's why our 4x ends up in a set of out in front of a set of parentheses. And what we're going to do is we're going to factor 4x out of each term, and then whatever we have left is going to go inside here. So factoring works like division. If you have 20 and you factor out a 4, that's going to leave you with 5. We just do 20 divided by 4. Now the variables we think about a little bit differently. If we have x cubed and if we factor out 1x, how many x's are left? And you have 2 x's left, which is why this is going to be an x squared. We'll bring down our plus sign. Now the 16, when we factored out the 4, we divided out of 4, which leaves us with 4. And then we have an x. Well, we factored out the x, so there is no x with this 4 over here, so this is our factored answer. Let me clean it up a little bit. Greatest common factor was 4x. When we factored it out, we were left with a 5x squared plus 4 inside our parentheses. All right, next example, greatest common factor. First look at your numbers. You have a 4, a negative 12, and an 8. The biggest number that fits into all 3 of those is 4. And then how many m's do all 3 terms have in common? Well, here's an m to the 4th. They don't all have 4 m's. Here's an m squared. They don't all have 2 m's. Here's just an m. All 3 terms have an m to the first power. So 4m is our GCF. And then we're just going to go through and we're going to factor 4m out of each term. Well, this 4 divided by the 4 leaves you with a 1. And then the m to the 4th, when you factor out an m, it leaves you with m cubed. Now this 1 is optional, the 1 in front of the m cubed. You can write it or you don't have to write it. Doesn't really matter to me. I'll bring down the minus sign. Now we're going to factor a 4m out of the second term. So that negative 12 divided by 4 is a negative 3, so there's our negative 3. We had m squared. If you factor out an m, it leaves you with just 1m. All right, plus, now we're going to factor 4m out of this last term. When we factor the 4 out, 8 divided by 4 is 2. And then we had an m. When we factored the m out, we weren't left with any m's. So this is our factored answer. All right, next example, greatest common factor. You have a 9 and a 45, so the biggest number that fits into both is 9. And then how many x's do they have in common? We have our x cubed and our x squared. So x squared is the most that they have in common. Then you have your y squared and your y. So y to the first power is the most that they have in common. So that is your GCF. We're going to go ahead and factor that out of each term. When we factor it out of our first term, the 9 divided by 9 is 1. We had x cubed. When we factored out x squared, it left us with an x. And then we had y squared. When we factored out our y, it left us with just a y. So that 1 is optional. Have 1 xy. Sometimes, if that bothers you, you don't need it there. You can have just your xy. Plus, now we're going to factor our GCF out of the second term. So 45, when we factor out the 9, that's division. 45 divided by 9 is 5. We have x squared. When we factor out our x squared, it doesn't leave us with any x's. So we move on to the y's. We had a y, but we factored out a y in our GCF, so we aren't left with any y's either. So that is going to be our factored answer. All right, one more. Let's see, we have, you look at your numbers, 14, 63, negative 7. The biggest number that fits into all three of those is a 7. And then you look at your x's. How many x's do all three terms have in common? That's just going to be, they all have, the most that this last term has is an x to the first power. So that's the most that they can all have in common. And then how many y's do they have in common? And that's going to be y squared. So we're going to factor our GCF out of all three terms. So when we start with our first term, we factor the GCF out. 14, we factor out the 7 is like division. 14 divided by 7 is 2. And then you had x cubed, and we factored out an x, so it left us with x squared. We had a y squared, but we factored out a y squared, so we don't have any y's in this term. Bring down your plus sign. Now we're going to factor the GCF out of the second term. 63, factor out a 7, it leaves us with 9. 63 divided by 7 is 9. We had an x squared, we factored out an x, so it leaves us with an x. And then our y cubed, when we factor out y squared, leaves us with a y. Alright, minus, now this 7, when we factor it out, 7 divided by 7 is 1. We have an x, but we factored out the x, so we don't have any x's left over. And then y to the fourth, we factored out a y squared, so that's going to leave us with a y squared. Now, one thing I haven't mentioned yet, you can always check your answers when you factor out your GCF. You can do that by distributing back in. You know, this greatest common factor, if we were to multiply it back in to all three terms, you should end up with your original answer. That's one way that you can check factoring using the greatest common factor.